So another use case I use Docker very heavily is for integration tests, where I want to spin up like a real database rather than having mocked in-memory databases. So I want to run my tests against that real database. Because even things like I've had before where I've used in-memory databases, that has passed when actually the real code caused a deadlock issue. Where actually using a real database, it captures all these issues. It's a bit more real. We don't have to mock stuff out. So if you grab the code for this section, we'll see that there's a Docker course API.test project. Now this isn't a course on .NET, so I've written it in advance, the code. But I'll talk you through it. There's not that much to it, but a lot of other platforms like Node have a similar concept of doing API tests, which is what we're doing here. So go into tests and go into API tests. Just got a single test for this demo, and basically it's going to do a GET REST request to our podcast endpoint, and it's just going to make sure that we get an OK 200 status code back. The way we do this with ASP.NET Web APIs is with a web application factory, and we can see on line 11 that I'm creating a web application factory here, an actual custom web application factory, which is just I've created a class which derives from web application factory, which allows customization, which I'll show in a bit. But basically, this is the arrange part of the test. It's getting an HTTP client, and behind the scenes, the test is spinning up our API in memory and returning an HTTP client. Then we can use that HTTP client to just do a GET request. So it's quite a high-level test, testing the requirement of the API. You're acting as the caller of the API rather than doing a unit test. And the final bit is the assert. So we're basically saying the status code should be OK. If we go to program, so this is our actual code, our endpoint, do you remember this used to be hard-coded? So because we're using localhost sometimes, database, the Docker Compose service name, other times as the DNS entry in the connection string, I thought rather than hard-code it, I would just go through .NET configuration. So I'll quickly show you how to do this. It's not that complicated. On line 10, we can see that I'm basically telling the configuration system to bind to a settings class. And then we're just injecting in that settings class via iOptions, and then we use it. So it's really simple to do. If I go to that settings class, it's just a class with a property called connection string. So we get our settings statically typed, which is quite nice. If we go to app settings.json, we can see I've just added it here and left it as the value I had before. So it's just using database. But in the test, I want it to be localhost. So this is where this custom web application factory comes in. If I go to this, this just allows me for the test to override these settings. And here I'm just saying localhost. So now we just need to spin up the database so that we can run our test against it. So if I do docker compose up database, now remember that you can do that. You can just do docker compose up and then choose a single service, or you can list out multiple services. Then if we go to a new tab, we've got our database running now. Then we can run our database seed. So if you remember, that was in the Docker file to actually create the database and seed some podcast test data. So again, remember that we can use docker compose. So we can, just like we do docker run something, we can use docker compose run and optionally specify a service name, and it's like doing docker run, but with the settings in the YAML file. So that's now created the database in SQL Server and populated our data. And just a reminder, in the Docker file, this is the database seed that I was talking about, which we covered earlier on in this course. And finally, the last change I made in the Docker file itself, I've just added .NET test. Now remember, the run command in the Docker file is just running a shell command. So this is just another .NET CLI command we're running as part of the build. So we're running all the tests. So if we go to the command line now, and we can do our Docker build. So usual, we specify the Docker file for the API, we run this. Now this is going to fail, and it's going to fail for the same reason as we've seen it fail before, where, do you remember how I said that localhost in the container is in the container? So it's not going to be able to access SQL Server that's in a completely different container. So the way to fix this is, if we do Docker build again, there's another argument called network. Now I'm going to talk more about networking later on in the course, but this option basically says use the host's network stack. So this will mean that when this container uses localhost, it's just like in Rider, if I run the test in Rider using localhost, so it can access the database just the same way as my local machine can do, i.e. the host. And that's now worked. So just to make sure that it's going to fail if the test is wrong, let's go back to Rider, and I'm going to change the SQL just to make it invalid. Then if we go back and do the Docker build again, then hopefully this should fail. And it has. So we can see that we've got our status code was expected to be 200, but was 500, which is kind of what we expected because it's a 500 error through an exception because it's invalid SQL. So we've got that working locally, but we also need to make sure that it's doing the same thing in our CI/CD pipeline. So if we go to our GitHub Actions, and I've made a few changes in here, so I'll just highlight them. First of all, we've got the spin up database and seed database. So this is literally a bash command in GitHub Actions, and we're saying docker compose up -d for detached database. So you already know what that does. It's just spinning up the database in the background in Docker. The seed database step, so line 30, that's just making sure that the script to seize the data has got the right permissions, because it was failing saying it didn't have the Linux execute permissions. Then once that's done, then line 31, that is doing our docker compose up. Now remember that database seed has that script that waits, this wait and run, waits for the database to be available. So that means that once this is run, then the next step, build, at that point we know that SQL Server is up and working and the database has been seeded. So if we just did line 26, docker compose up -d, and that's running in the background, and then we run our tests, there's going to be a bit of a race condition, but the seed database, which does this wait anyway, means that when our tests run, we know that SQL Server is up and running and everything's good. And another change I've made here, you can see I've commented out the build and push, the Docker action, and I'm using raw bash commands instead, the Docker CLI. The reason I've done that is, on line 55, you can see I've specified network host. I found that didn't work. I don't know why it wouldn't connect to the database, but specifying network host on line 42, when using the raw commands like we've done locally, that did work. So I don't know the reason, but that's why I've commented that out. To be honest, using the raw Docker CLI commands, that gives us more flexibility anyway. So if we look at this on GitHub Actions now and look at spin up database, then this should all look quite familiar. It's just pulling down the images, and then container database creating and created and started. And then we've got the seed database, which we can see is doing the seed, which we've already seen that. So SQL Server ready, and then it's running our SQL script. Then build, basically what we've already seen, but we can see it's running the test here as well. So that's passed, and push is pushing that up. So notice that it says layer already exists. So again, just like the pull, where some of these layers are cached, the push does the same. So if the layer already exists on Docker Hub, then it's not going to have to push that every time. And some of the base layers, that's going to already exist. So it's not going to do that. It's just going to do the ones that have changed in our build from the last build that was pushed. And then tear down database. If we actually go to the GitHub action now, the code, notice that I've got if always. Now the reason for this is because if our tests fail, normally without this if always, the pipeline, the GitHub Actions would stop processing, but this just says, regardless of if something failed beforehand, still do the teardown, because if the test failed, we still want to get rid of our database afterwards. So this is just a simple example showing a single integration test running against a SQL Server instance spun up with Docker. We're leveraging Docker for multiple things here: spinning up SQL Server, seeding the database, building our image, which includes running the tests, and then we tear down the database afterwards. Note that this same pattern can be used for many data stores, not just SQL Server. It can also be used for message brokers like RabbitMQ, or storage like Azure Storage with the Azurite image. So another good use case is for very quickly spiking stuff. So imagine I've got a requirement. I've never used Redis before, but Redis feels like the perfect technology to use, but I don't know. I just want to try it out. I've never used it before. And I don't want to start installing it on my machine, installing software. I just want to spin it up to have a play around with it. Docker's perfect for that. So go to Docker Hub, search for Redis, I'm pleased to find there's an actual image, so I can take that one. It's just called Redis, so if we jump over to the command line, type our usual docker run, this is the port for Redis, the default port, and then Redis, press enter. So I've now got Redis running and I've not had to install anything. And I can go to my code now, and this is LinkPad, so this is just a quick way of spiking .NET code, writing some .NET code. But whatever your language is, just write some code that runs against that. So in this example, I'm using the Stack Overflow Redis NuGet package, and I'm literally just writing a value and then reading it back and dumping it out. So if I press F5 now, then we can see it successfully read that value back. So how easy was that, just to quickly spike a data source, spin it up, use it, tear it down once I've finished with it. And that applies to so many different things. Redis, RabbitMQ, SQL Server, MySQL, any of these databases or any software that's an image on Docker Hub. It's just so easy to spin stuff up and tear it down after you finish with it. So with what we've learned so far in this course, if you delete a container, the data goes as well. So imagine your container is SQL Server, you've inserted some records, you've got some databases, you delete the container, that data's gone. But if we don't want our data to be that transient, we can use things called bind mounts or volumes. So looking at this diagram, imagine this is my host machine. This bit is Docker stuff I've got installed. So I've got some containers running. I've created a few volumes, which we'll look at very shortly. I've got a directory with some stuff in on my host file system. So imagine this container is SQL Server. So at the moment, if I delete it, the data is gone. However, if I've created a volume, then what I can do is create a virtual directory inside that container. It can be any directory inside that container. So in the case of SQL Server, it would be the directory where SQL Server looks for its data, and we'll look at that in a sec. And a volume is just something you create in Docker via this Docker CLI, which we'll do very shortly. And that is basically a directory that is managed by Docker, but it's outside the container. So that's the key point. So if you delete your container and you create a new container from the same image, but point at the same volume, then your data is still going to be there. In fact, you can actually point two containers at the same volume or multiple containers, and they will share the same shared directory. Another option you have is something called bind mounts. And this is basically doing exactly the same thing, but that directory points to some directory on your host file system. And this could be a config directory, it could be binary files, it could be whatever you want. But the point is, the software inside the container will think that the directory you've bound it to, i.e. this directory, is inside the container when it's not, it's outside the container. Quite often, you will hear that people refer to this as volumes as well. In fact, the Docker CLI, the -v command, which we'll see shortly, does both bind mounts and volumes, but they are kind of separate concepts. You've also got this thing called tempfs, and this is basically in memory. So you can do exactly the same thing, but one difference between bind mounts and volumes is that where the lifetime of a volume in a bind mount can be longer than the container, the tempfs is just the lifetime of the container. If you remove the container, then this data goes away as well. One of the benefits of this is when you're writing to a normal directory inside the container, that's writing to, it's called a writable layer of the container, but it's writing to the file system, where if you want it to write in memory, then this has some performance benefits. So in the next section, we're going to look at how to create these volumes ourselves.